A very warm welcome everyone. So today in this class we are continuing Unit 14 Atomic Structure and Chemical Bond, Class 9 under the subject Science and Technology. I hope you all are prepared with all the materials that you need for your class, your notebooks and pens. So without further ado, let's get started. Now let us revise the certain points and topics we have already studied in previous class. So a duplet. Duplet is the tendency of an element to hold maximum 2 electrons in its outermost orbit. It is duplet, but similarly, if the element has the tendency to hold maximum 8 electrons in its outermost orbit, then it is known as an octet. So, we have already studied the examples of certain noble gases that are in duplet and octet state. Do you remember the gas that was in duplet state? Yes, it's helium. So helium has 2 electrons in its outermost orbit, hence it is in a duplet state. Similarly, neon, argon, krypton, xenon and radon have 8 electrons in its outermost orbit, so it is in octet state. And these all have full number of electrons in its outermost orbit, so that's why they do not readily take part in the chemical reaction. That's why these all are known as noble gases. Now let us revise chemical bond. So what is a chemical bond? So chemical bond is the force with which the atoms of an element that is present in the molecule they combine is known as the chemical bond. So the force with which the force between the atoms of an element that combine to form a molecule is called a chemical bond. And we studied about two types of chemical bond, that is electrovalent bond and covalent bond. So now electrovalent bond was formed by transfer of one or more than one electron from one atom to another atom. So that type of bond is known as electrovalent bond. Whereas covalent bond was the type of bond that was formed by sharing of one or more than one electrons in its outermost orbit with another one or more than one atoms is known as a covalent bond. So we also studied an example of electrovalent bond, that was sodium chloride, that is salt we use in our daily life. So a sodium chloride has sodium and chlorine element. So sodium has 1 electron in its outermost shell and chlorine has 7 electron in its outermost shell. So for sodium to reach octet, it should donate 1 electron, and for chlorine to reach the octet, it should receive 1 electron. So the sodium, it donates its outermost electron to chlorine to form a sodium chloride molecule. And the bond that they share is formed by transfer of electron from sodium to chlorine. That's why they form an electrovalent bond. Now since sodium, it transfers its electron to chlorine, it becomes electropositive because it lacks 1 electron. So 1 number of proton is more, so it gains a positive charge. So it becomes electropositive, whereas chlorine, it receives 1 electron, so it has more negative charge, that is 1 electron is more, so it becomes electronegative. So covalent compound has electropositive and electronegative elements in them. Now another example we studied of covalent compound was ammonia. So the molecular formula of ammonia is NH3. So it contains 3 atoms of hydrogen and 1 atom of nitrogen. Each hydrogen has only single electron in its outermost orbit, whereas nitrogen has 5 electrons in its outermost orbit. So it now needs 3 more electrons to reach the octet state. So what they all do is they all share single electron with each other so that the hydrogen reaches the duplet state, as you can see here, and the nitrogen, it shares electron with all of these 3 individual atoms of hydrogen to reach the octet state. Now since they share single pair of electron between each other, it is represented by a single straight line, that is single covalent bond between nitrogen and each atom of hydrogen. Now today in this class, we will be studying in detail about molecular formula and molecular weight. So before understanding how to write a molecular formula, what is a molecular formula, how to calculate a molecular weight, let us study how certain molecules are formed. So first of all, magnesium oxide. So magnesium oxide has a molecular formula MgO. So magnesium has 2 electrons in its outermost orbit and oxygen atom has 6 electrons in its outermost orbit. So magnesium has to get rid of 2 electrons from its outermost orbit to reach the stable octet state, whereas for oxygen it should receive 2 electrons to reach the stable octet state. So what they do is, the magnesium, it donates 2 electrons to the oxygen atom, and during this donation what happens? Magnesium becomes electropositive, oxygen becomes electronegative, and this is how magnesium oxide is formed. Now here you can see that one atom of magnesium reacted with one atom of oxygen and they both reached a stable octet state to form, and they also form magnesium oxide. But the same magnesium atom, when it has to react with chlorine to form magnesium chloride, what does it do? So magnesium has 2 electrons in its outermost orbit while chlorine has 7 electrons in its outermost orbit. So magnesium has to get rid of 2 electrons to reach the octet state, but chlorine only can accept 1 electron because it already has 7 electrons in its outermost orbit. So what happened is, the same magnesium now it reacts with 2 chlorine atoms. So 1 electron that is present in outermost orbit, it donates to 1 chlorine atom, and the another remaining 1 electron after donating 1, it again donates to another chlorine atom. So they form MgCl2, that is magnesium chloride. So magnesium, it donates 1 electron to 1 chlorine and another electron to 1 chlorine. So you can see that in the formation of magnesium oxide, the magnesium only reacted with single atom of oxygen, but the same magnesium now then reacted with 2 different atoms of chlorine to form magnesium chloride. So we can say that during these all depends upon what? The number of electron that is present in its outermost orbit. So it depends upon the valency of the element. So molecular formula depends upon the valency of the element, and the number of atoms to take part in a chemical reaction to form a molecule also depends upon the number of electron that a certain atom of the element have in its outermost orbit. So now let us study what a molecule is. So molecule is 2 or more atoms that are connected by a chemical bond and forms the smallest unit of a substance. They can be element or a compound, and which retains the property of that substance. So I have explained 4 things over here. The first thing is, molecule consists of 2 or more atoms. The another thing is, molecule is connected by a chemical bond. They can be any type of chemical bond, covalent or electrovalent, or any other bonds. And the another thing is, they form the smallest unit of a substance. They can be element or a compound. So the example is, the smallest unit of the substance O2 is an element oxygen that forms O2 molecule, and here it is water compound. Now the molecule also forms the smallest unit of a substance. It can either be an element such as oxygen or a compound that is formed by 2 different elements or 2 or more different elements. And the fourth thing is, the molecule retains the property of that substance. So these are the 4 things you must have to become a molecule. So molecule are 2 or more atoms that are connected by a chemical bond, and form the smallest unit of a substance which retains the property of that substance. Then this is known as a molecule. So what is a molecular formula? Now the symbolic representation of a molecule which also gives us the total number of atoms that is present in that molecule is the molecular formula. So it is a symbolic representation of the molecule. Now here we have an example of oxygen molecule. So oxygen molecule has the symbolic representation, that is molecular formula O2, and it also gives the total number of atoms present in oxygen molecule, that is O2 means 2 number of oxygen atom is present to form an oxygen molecule. Similarly, in H2O, you can see that there is 2 atoms of hydrogen which has a chemical bond to one single oxygen atom. So these two representation, that is symbolic representation, is the molecular formula of oxygen and water respectively. Now let us study a few molecular formulas examples. So the molecular formula of sulfuric acid is, yes, it's H2SO4. Similarly, ammonia, NH3. And it also shows that to form one molecule of sulfuric acid, you need 2 hydrogen atom and a sulfate radical, and to form ammonia you need 1 nitrogen atom and 3 hydrogen atom. Similarly, calcium oxide CaO, hydrochloric acid HCl, phosphoric acid H3PO4, silicon dioxide SiO2, calcium carbonate CaCO3, ammonium nitrate NH4NO3, sodium chloride NaCl, and carbon dioxide CO2. Now let us try to understand the methods of writing molecular formula. So there are a fixed set of rules that you must follow to write a molecular formula. So let us study about all those rules by using one example of sodium chloride. So the first rule is you must write the name of the molecule that you have to write the molecular formula of. So we have sodium chloride. So we already completed the first step. The second step is you should write the symbol or the formula of the element that is present, element or radical present. So here we only have the element, so we have to write the symbol of these elements. So the symbol of sodium is Na and the symbol of chloride is chlorine Cl. So the second step is also completed. Now the third step is you should write down its valency. So the valency of sodium is, yes, it's 1. And the valency of chlorine, it's also 1. So this is our third step. Now the fourth step is we should exchange the valencies. So we should exchange the valency. We should give the valency of chlorine to sodium and sodium to chlorine by crisscross method. So exchange sodium, it goes 1, and we again exchange this valency of chlorine with sodium to get 1. So this is the fourth step. And the final step is we should write the molecular formula. Now since these both have, first of all, they have the same valency, and on top of that it is 1. So we can neglect this and simply write NaCl. Now this is the molecular formula of sodium chloride. Now let us revise the rule again by using another example, that is ammonium sulfate. So the first thing is we should write the name. We already completed the first step. Now the second step is we should write the symbol of an element if it is an element, or the formula if it is a radical. Since here we have ammonium and sulfate, both of them are radical, so we should write the formula of the radicals. So NH4 and sulfate SO4. Now the third step is you should write the valency. So the valency of ammonium is Yes, it's 1. And the valency of sulfate is 2. So, the another step is we should now exchange the valency by crisscross method. So, NH4 and SO4. Now, there's one thing you must keep in your mind. If you are writing the molecular formula of a radical and you have to exchange the valency, you must place a bracket. After that, we get 2 and 1. So, why should we place a bracket? There is 2 reasons. One basic simple reason is to avoid the confusion. If there was no bracket here, we would have understood it's NH42. So, to avoid that confusion. And the another thing is, what this means is two radicals, that is entire 2 NH4 radical and one single sulfate radical. We should indicate the bracket and the valency indicates that. So, if we place a bracket, what we can understand is 2 NH4 and 1 SO4. That's why you should place a bracket while you are writing the molecular formula of a radical. So, after crisscross method, NH4 gets 2, sulfate gets 1. So, what happens now? Now, since this is 1, we can neglect it. So, the final molecular formula becomes NH4 whole 2 SO4 for ammonium sulfate. Now, let us revise the rule again so that you will remember it. So, the first rule was you should write the name of the molecule whose molecular formula you are writing. So, let us take an example of magnesium chloride. So, the name is magnesium chloride. The second step is you should write the symbol if it is an element or formula if it is a radical. So, since these both are elements, so we should write the symbol magnesium Mg, chloride Cl. Now, the valency, we should write the third step, that is the valency of each of these elements. So, magnesium has valency 2 and chlorine has valency 1. The fourth step is we should exchange the valencies by crisscross method. So, in this way, magnesium gets 1 and chlorine gets 2. So, now 1, you do not have to write 1. So, the final molecular formula of magnesium chloride becomes MgCl2. Now, let us take another final example to understand the process of writing molecular formula. So, if you have to write the molecular formula of calcium bicarbonate, the first thing is you should write the name. So, the name is calcium bicarbonate. Now, you should write the symbol or the formula of the element or the radical. Now, calcium element has symbol Ca and bicarbonate radical has formula HCO3. Now, another step is we should write the valency. Calcium has valency 2, bicarbonate has valency 1. And the fourth step is you should exchange the valency between them. And so, after exchanging the valency, calcium gets 1 from bicarbonate and bicarbonate gets 2 of calcium. Now, you don't have to write 1, so neglecting 1. So, the final molecular formula we get is CaHCO3 whole 2 for calcium bicarbonate. Now, we already studied about how we can write a molecular formula. Now, let us understand why we are writing this molecular formula. What advantage do we get by writing the molecular formula? So, the advantages of writing molecular formula are, the first advantage that we can get is the molecular formula, it tells us what elements the compound contains. Suppose here we have ammonia, example of the compound ammonia. So, looking at this molecular formula of ammonia, we can easily say that the compound ammonia contains nitrogen and hydrogen elements. So, the another advantage is the molecular formula also tells us how many atoms of each element are present in one molecule of that compound. So, taking an example here again, ammonia, looking at this, we can already say that it has 2 elements, nitrogen and hydrogen. Now, from this we can see that the ammonia compound contains 1 atom of nitrogen and 3 atoms of hydrogen to form 1 molecule of the compound ammonia. And the final thing it says is, it also tells us the valency of the element and radical in most of the cases. Like here you can see that the valency of hydrogen is given to nitrogen, so nitrogen is 1, so valency of hydrogen is 1, and the valency of nitrogen is given to hydrogen by criss-cross method, so you can say that the valency of nitrogen is 3. Now we already understood how to write a molecular formula. Now let us study how we can write or calculate or find the molecular weight of a certain molecule or a compound. And for that, to find the molecular weight, we must have the concept of atomic weight. And to study about atomic weight, let's recall a very little about what an atom is. So atom is the smallest particle of an element which can take part in the chemical reaction. Here you can see an atom. An atom contains nucleus in the center, and the nucleus contains protons and neutrons, which is represented by green and pink. And electrons reside outside the atom in their orbits, and they revolve with a certain speed around the nucleus. So this is the basic structure of an atom. And at end, what is an atom? It is the smallest particle of an element which can take part in the chemical reaction. Now what is an atomic weight? So atomic weight of an element is the sum of the number of protons and the neutrons present in nucleus of one atom of that element. We just studied about the structure that nucleus contains protons and neutrons. So atomic weight is the sum of that proton and neutron that is present in the nucleus of one atom of an element. So we can also say that atomic weight or atomic mass is the sum of number of proton and the number of neutron that is present in the nucleus of one atom of that element. Now let us try to calculate atomic weight of some elements. So element oxygen. We all know that element oxygen has 8 number of protons. It has 8 number of neutrons. So the atomic weight is, yes, 16, because atomic weight is the sum of the number of protons and the neutrons. So 8 plus 8 is 16. Now let us take another example of lithium. So lithium, how many protons does it have? Yes, it has 3 numbers of protons and number of neutrons is 4. So lithium has 3 numbers of proton in the nucleus of one atom of an element, and it has 4 numbers of neutrons in the nucleus of one atom of that element. So the atomic weight of lithium will now be, yes, it becomes 7. 4, that is number of neutron, plus 3, that is number of proton, that is 7. Similarly, carbon. Carbon has 6 number of protons. It has 6 number of neutrons. So the atomic weight of carbon becomes 6 plus 6, that is 12. Now we already understand what an atomic weight of an element is. Now let us see what a molecular weight is. So the molecular weight is the sum of the atomic weight of the atom that is contained in the molecule. So a molecule is made up of many atoms. So a molecular weight is the sum of individual atomic weight of the individual atom that is present in one molecule. So the sum of all the atomic weight of all the atoms that is present in that molecule gives us the molecular weight. Now let us try to calculate the molecular weight of certain molecules. So the first example we'll take is lithium oxide. Now let us try to find the molecular weight of lithium oxide. Now the molecular formula of lithium oxide is Li2O. So here you can see that to form a molecule of lithium oxide we need 2 atoms of lithium and 1 atom of oxygen. So, as I mentioned earlier, the molecular weight is the sum of the atomic weight of all the elements, all the individual elements. Even though the atoms are repeated, but still you have to assume it independently. So, individual atoms, individual atomic weights sum gives us the total molecular weight of the molecule. So, here you have 2 atoms of lithium. So, 2 times the atomic weight of lithium gives us the total atomic weight of 2 lithium plus the atomic weight of oxygen, and there is only 1 atom of oxygen, so 1. So, the atomic weight of lithium is 7 and the atomic weight of oxygen is 16. So, 2 times 7 plus 1 times 16. So, 2 times 7 is 14 and 1 times 16 is 16. So, the molecular weight of lithium oxide is 30. Now, let us take other example as well to find the molecular weight of other molecules. So, aluminium chloride. Aluminium chloride has the molecular formula AlCl3, aluminium chloride. From here you can see that to form a molecule of aluminium chloride, we need 1 atom of aluminium and 3 atoms of chlorine. So, 1 times the atomic weight of aluminium plus 3 numbers of chlorine atoms, so 3 times the atomic weight of chlorine. So, atomic weight of aluminium is 27, atomic weight of chlorine is 35. So, 27 plus 105 gives us 132. So, the molecular weight of aluminium chloride is 132. Now, another example is that of sodium hydroxide. Here you can see that hydroxide is a radical. Even though there is a radical, we have to assume the atomic weight of individual atom. So, sodium, there is 1 sodium atom, 1 oxygen atom and 1 hydrogen atom. So, 1 times the atomic weight of sodium plus 1 times the atomic weight of oxygen plus 1 times the atomic weight of hydrogen. Now, the atomic weight of sodium is 23, atomic weight of oxygen is 16 and atomic weight of hydrogen is 1. So, the total sum is 40. So, the molecular weight of sodium hydroxide is 40. Now, we have come to an end of this lesson. So, now let us try to test our knowledge about everything we studied in this class by trying to solve a few questions and answers. So, the first question is, we have 1 statement and 2 arguments. And among these 4 options, one of them is the correct option. So, the statement, molecular weight of a compound is the sum of the atomic weight of the atoms contained in one molecule of that compound. Is it true? Yes, it's true, because as I mentioned earlier, molecular weight of a compound is the sum of the atomic weight of all the atoms that is present in that one molecule of compound. So, the statement is correct. So, let us see if the remaining arguments are correct or not. So, argument 1, it means molecular weight. So, molecular weight is equal to the sum of the number of protons and the neutrons of the nucleus in one atom of an element. Is this true? No, it's not true, because this is not the molecular weight, it is atomic weight, because atomic weight is the sum of the number of protons and the number of neutrons that is present in the nucleus of one atom of element. So, argument 1 is the incorrect definition of molecular weight, because this is the definition of atomic weight. So, argument 1 is incorrect. Now, argument 2. The atomic weight of an element is always less than the atomic number of that element. Is this true? No, it's not true. Why? Because atomic weight is the sum of the number of proton and the neutron that is present in the nucleus of one atom of an element, whereas the atomic number is the number of proton that is present in the nucleus of one atom of that element. So, since atomic number is only the number of proton, whereas the atomic weight is the sum of the protons and neutrons. So, atomic weight is mostly greater than atomic number. But in case of hydrogen, there is no neutron. So the atomic weight of hydrogen is 1 and the atomic number is also 1. Except that in every cases, the atomic weight of an element is always greater because it is the sum of the number of protons and the neutrons. But the atomic number is the number of protons only that is present in the nucleus of one atom of that element. So the atomic number is less. So atomic weight should always be more, except in the case of hydrogen. So the argument 2 is also incorrect. So the correct answer is option 1 because only the statement is correct. Now let us try to solve another question. Find the correct and incorrect arguments from the following. So here we have 4 arguments. Now let us see if they are correct or not. The first argument, crisscross method is used to find the molecular weight of the compound. Is this true? No, it's not true. You should not be confused. Here it says molecular weight. But crisscross method is used to find the molecular formula, but not the molecular weight of the compound. So the first argument is incorrect. The second argument, molecular formula of aluminium oxide is AlO. Is this true? Let me show you guys. Now, aluminium oxide. So first we have to write the name while writing the molecular formula, then the symbol or the formula. Here we have symbol. The valency of aluminium is 3 and the valency of oxygen is 2. So after crisscross method, aluminium gets 2 and oxygen gets 3. So the molecular formula of aluminium oxide is Al2O3. But here in the argument it says AlO. So argument 2 is incorrect because the molecular formula of aluminium oxide is Al2O3, not AlO. So the argument 2 is incorrect. Now let us see argument 3. The smallest unit which can take part in the chemical reaction is an atom. Is this true? Yes, it's true because that is the definition of an atom. Atom is the smallest unit of an element that can take part in the chemical reaction. So option 3 is correct. Now let us see if the argument 4 is correct or not. All the compounds can be shortly represented by the molecular formula, but only few elements are represented by their molecular formula. This is quite confusing, but can you guess if this is right or wrong? It is correct. Now this is a little confusing because here what it says is all the compounds can be shortly represented. That is a representation of a compound, that is a molecular formula. So all the compounds can be represented by a molecular formula, but only few elements are represented by molecular formula. We all know that the elements are usually represented by their symbol, but there are a few elements that do not stay in its atomic form. It stays in diatomic form, such as oxygen, nitrogen and hydrogen. Here you can see nitrogen and oxygen, they exist in this way, forming a covalent bond between them. They do not exist in a single atomic form. So they are diatomic molecules. So these type of elements are represented by their molecular formula, that is O2 and N2. So they cannot be represented just by their symbols. So that's why the fourth statement is correct. That is, all the compounds can be shortly represented by their molecular formula, but only a few elements are represented by their molecular formula. Now let us try to solve this final question. So, which of the following elements have same atomic number and atomic weight? Oxygen, nitrogen, hydrogen or helium? I'll give you a hint. I've already explained this previously while we were trying to solve one question. Yes, it's hydrogen because hydrogen has no neutron. So it contains one proton. So that's why its atomic number is 1 and atomic weight is the sum of neutron and proton. So 1 plus no neutrons, that is 0. So its atomic weight is also 1. That's why the element that has same atomic number and atomic weight is hydrogen. So in today's class, you studied how you can write a molecular formula of certain molecules, how you can calculate the molecular weight of a molecule by using the same molecular formula that you learned to write. And we also solved a few questions related to this chapter. So now I'll see you guys in the next class.